that would be swell. I would enjoy that. So anyways, let's get started. Let's switch over to my monitor here. And as you see, I've got my Kali box running inside a VMware workstation, and then we've got SickOS running. Oh, hello. SickOS running in VMware workstation as well. As you know, unlike the last couple ones, we don't have an IP address in the MOTD, which sucks, but we can take care of that pretty quickly. We'll just need to do some network discovery. First, I kind of want to talk a little bit about why I chose this one. I was looking around for OSCP-like vuln VMs. I know that a lot of the people that follow me on Twitter are either looking to get their OSCP or, you know, have just gotten it, or that's kind of roughly the level that we're all working at, right? So I found this site. It's got some really interesting, it's got a whole list of OSCP-like VMs from Vulnhub. I'll probably be working through them as we go. Lord of the Root isn't on here. I would have probably included that personally, but you know, oh well, no list is perfect, right? Maybe one day I'll create my own list. I don't know, but it looks like they didn't finish SickOS. I would probably put it in the intermediate. I wouldn't call it a beginner friendly one. It's probably around about the same level of difficulty as Lord of the Root. It doesn't require a buffer overflow, but it does require some privilege escalation and operating system enumeration. And there's a couple gotchas kind of along the way that we'll go over that make it a little more difficult than what I would consider beginner friendly. But certainly if you've done a few vuln VMs before, you've watched some of my other videos, you're probably ready for something like SickOS. So what we're going to do is we're going to find out where this guy is. Now, we've had a few Boot2Root so far, so we can probably make an educated guess where this VM is on the network. If you've watched previous videos, or if we're coming at this completely cold, obviously we do something like nmap sn for just a ping sweep. We don't want to do port scanning on like a whole empty network. We just kind of want to know where, you know, what the where the vulnerable VM is. So we're in 192.168.4.7. So we'll do at least that. Now, if this was cold, this was completely cold, we'd probably do a ping sweep of the entire network, something like this. Or, you know, even assuming that the gateway is 1 or 2, we'd do like, you know, 3 or whatever. We'd do like through 255 or 254, whatever. We're not going to do that because I have a pretty good guess that this is going to be 47.129, because that's kind of the pattern that we've been seeing before. Even if it's not 129, it's probably going to be within that 1.2 or 1.3 range. So let's just speed up, you know, what we're going to do by taking some educated guesses. And this is also important when you're on engagements or in a CTF or any sort of competition or whatever. Time is always, always, always of the essence. So if you can kind of parallelize, if you can do things concurrently and save yourself some time, that's great. So you can like kind of kick this off as like a you know, it'd be like, okay, I'm going to do my 1 through 255 for a sure thing, right? But on the, wow, that came back really fast. Did I not set this up correctly? I didn't set this up correctly. It's on the wrong net. So, and unfortunately, this thing doesn't like, it only pulls when it comes up. So we're going to have to restart it. So always test your stuff before you start. What I usually do is I'll take a snapshot of the VM before I start working on it, and then I'll work through it and then revert to snapshot. I obviously didn't do that this time. I forgot to take the snapshot, so I like wiped it out and re-imported it and then didn't reset it up. Anyways, so now it should be in this range, so we'll go ahead and do that. But we could probably, a lot of times that'd be slower, but you could also just take an educated guess, right? You take this and then you're like, well, I'm 128, so this is probably 129. Boom, it's up. that's right. But anyways, I just wanted to show you both ways. It's important, like I said, to kind of take shortcuts when you know that you can. So we'll do our standard -A. We'll do every port. We'll put in the IP address. And we'll do the all output formats. And we didn't set up a working directory, right? Okay, so we're in our working directory. Now we're going to do this because we want to have all our notes for the same thing at the same place. So call this SickOS as the prefix. And while that's chunking away, we're going to do something pretty similar, except instead of all ports, instead of this -p-, we're going to do -p80 because a lot of the boot2roots that we've been dealing with previously have a web address, a web port open and not much else. So we'll take this educated guess. We'll say, okay, if the port 80 is open, let's take a look at that while this thing's crunching away, right? So we'll give that here. We'll put this guy on the other half, this guy on the other half. Come on. All right. Cool. So we don't need that. Oop. So we'll go ahead and boot up our burp suite as usual. Get that going. Burp suite free, of course. One of these days I'm going to buy a pro because it's just so damn useful and I want to support them. But I also want to make it overly abundant that nothing that I'm doing in these live streams require you to have the pro version. Everything's done kind of with open source stuff. So let's do the GP 2168. We're 47129. Oh, and we have an intercept on because we're going through the proxy. All right, so we get this cool, funny little meme, the woke Keanu Reeves, because it's funny. But not much else, yeah. Let's take a look at our web history. We'll take a look at our request. It's just a get HTTP, and there's nothing here. And in fact, it even tells us there's nothing in here. So there's not a lot going on. So what do? Before, we've done things like, I think I've shown you guys how to run Nikto. We've done some dir-b use, etc. For this one, I think we're going to use dir-b because if we look, here, there's nothing really going on. It's just flat HTML. There doesn't appear to be, I don't know, we can kind of enumerate this a little bit if we want. So it is a PHP site, probably. It is a PHP file. But there's no, this is just HTML. There's nothing really going on. So we don't have any leads to go on. And in fact, if we want, let's do it anyways. Let's do Nikto host 2168.47.129. Just to take a look at it. So Nikto is pretty noisy on the server. It lights up the log files like crazy. So it's not really recommended if you're in stealth mode. And it could be, it doesn't really do much to exploit. So it's not like it'll knock things over, all over the place. But if you have some sensitive stuff, I wouldn't really recommend it. It's useful for some situation, but as you can see, we're not really getting much from it. It's like, okay, well, it doesn't have the cross-site scripting protection header, so it could be possibly vulnerable to cross-site scripting, or at least it's not worrying about cross-site scripting. It's just some generic stuff here. Nothing cool. So we're going to use dir-b because we don't have a lot else to go on. And we'll do 129. And so see here, it's doing a dictionary of 4,612 words. The reason that I continuously use dir-b in these Boot2Roots or CTF challenges instead of dirbuster is because dirbuster just goes crazy. It either takes in word lists, which I guess we could just use the dir-b word list if we wanted, or it takes in large word lists or it brute forces, and we don't really want to brute force. We want it to be relatively targeted. Also, it's command line, whereas dirbuster, I don't know if it has command line version, but I've always seen it like spin up a GUI, and we don't need something that heavyweight for this, right? So if you look, here's the word list it's using, here's the number of words that it generated. Scanning this, found the index.php, and it also found test. Cool. So let's check out test. And it's got a directory listing. It's running light HTTPD, which we could find out from here, or it's important to always notice things in various places, right? Use different tools. Different tools give you different information, but also sometimes if something's lying to you, different tools might give you a different insight, right? So this is light HTTP. The headers say light HTTPD. That's probably what it's running. So, but if you notice, there's nothing here, which is unfortunate. So what do we do now? Well, now we're stuck, and because you have the benefit of walking through this with me, who has already done this, I can save you, 30 minutes to an hour of kind of doing some research and reading and enumeration. But what it really comes down to is the only attack surface we have is this /test and index.php against a light HTTPD server. So let's do some enumeration of the server itself. What is the server giving us access to? Well, there's a thing called, there's a method, and we'll real briefly go into HTTP methods in case you're unfamiliar. But if you notice, when we look at burp, we see this get, right? So get means fetch this thing. There's post is another one that you'll see often, which is post some information to a server. And it's deeper than that, but get and post are the most common ones that you'll see. So it's the type of HTTP request that your client is making, that your browser's making. So there's another special one called options. And if you'll notice curl -x, that's just saying what HTTP method do we want? And I'm saying I want options against, and I'm going to do -I because I only want the headers back. Let me do a man curl real quick. I'll show you these things. So and then we'll do -I. Oh no, that was wrong. That was the wrong syntax, sorry. So yeah, this is just showing I just want the headers from the response. And then we'll also what was the other one? X. So this is the type of requests that we're going to make. So just to give you a shot. And then, so we're going to go curl -X. We want options. I can't type. Yeah, -I. Do the 1216847.129. And we'll just do it against the root right now. And if you'll notice, pretty standard headers. And in fact, we have these headers here. So this is the same. Okay. So let's do it against test. Now, here's some more interesting information that we didn't have, right? And this is all part of enumeration. And if you don't know about HTTP methods, then you wouldn't have thought to check this stuff, but now you do. So, we're all better InfoSec professionals because of this, right? So if you take a look, we've got something called dav going on, whatever that means. It means quite a bit actually, but it not super pertinent to us. But what's super interesting is this. So we have these allowed methods that is bringing back to us, being returned to us. So we've got a bunch of methods that I don't even know what the hell they are. So prop find, make column, I'm not actually sure what copy does, prop patch, lock, unlock. This is all crazy stuff. Delete, put, move, I think I've used before. Options, get, head, and post are all interesting, normal, let's say normal-ish HTTP methods. So the cool thing is, put actually lets us upload stuff. Post lets us post data to a website, but really the website needs some form of interface to receive that. Put does too, but it's less. How do I phrase this? It's less formulaic, right? So post is for forms, really. When you post, you're putting the data that you're trying to post to the web server inside some form of variable structure in the body of the post request. Put doesn't require that at all. And if we have something like a directory listing like this, we should be able to just put a file directly into that directory, which is exactly what we're going to do. So if we look, we're going to man curl again. Oop. And curl. There we go. And we're going to take a look at the minus capital T option. And so this is upload file. Oop. So when we upload a file, really what we're doing is we curl minus T, file name, and then the URL that we're going to upload it to. So let's give this a shot. We're going to use verbose because we want to see what's happening. Minus capital T. We don't actually have anything to upload yet. We need something to upload. Let's upload something. That'd be swell, wouldn't it? Let's upload one of my favorite shells, the interpreter shell. So we're going to need cd to boot2root, and we're going to go into the SickOS. And you use MSF Venom, which we've used in previous videos. P payloads. I'm going to use the PHP interpreter, reverse TCP. Lhost is going to be 192.168.47128. The L port is going to be, let's use something like 42341. Why not? And we're going to pipe that out to shell.php because we're not being stealthy. All right, so we've got our shell. Cool. What else are we going to do? We're going to set up our listener. All right, so we're going to use that exploit multi-handler that we've used in the past. We're going to set the payload to the same payload we used before. I can never remember this crap. So we're going to set lhost to 192.168.47128. We're going to set the L port to all right, exploit minus J, which turns it into a job. So this listener is running in the background regardless of what we do in the foreground. Not only that, but if we get the shell come back, then the shell will also sit in the background waiting for us to become interactive with it. So now that we've got this shell, let's go ahead and we're going to curl. We're going to minus V so that we can see what's going on. Capital T is the flag to let us upload something. Upload our shell.php to 192.168.47129. Test is where we're uploading it to, right? So can't open. Wait. Oh, I'm in the wrong. Haha. Roots. SickOS. Let's try that again. Oh my god. We see a bunch of failed here. So let's see what's going on. So we use the put method to post our shell or put our shell to test shell.php using HTTP 1.1 to this host using curl. Everything's good so far. Now we see this weird header that I hadn't seen before. Probably don't see very often. It's expect 100 continue. So what this header does and what is going on here is this this call, this request is saying, hey, I've got a put that's 951 bytes long. I'm going to wait until you get back to me and say that you're going to let me upload it, because I'm not going to bother uploading 951 bytes if you're just going to cancel it, right? So I'm expecting a 100 continue response back before I start uploading. That's what this does. So then we get a response back, basically saying expectation failed. And we don't get a lot of information back here, right? It just says expectation failed, expectation failed. Took me probably like 10-15 minutes of Googling to figure out what's going on here. What I ended up doing is Googling for like 417 light HTTPD curl expectation failed or something like that. And I got this page. And so, you know, I wanted to show you, instead of just showing you the answer, I wanted to show you the page I found, kind of give you an idea of how we went about solving this, but also not take up, 20 minutes doing that searching for you. So what you'll notice here, the response is apparently curl uses this expect 100 continue that light HTTPD does not like. So what we can do is actually just cancel out that expect script or that expect header by explicitly defining our own expect header that's just empty. Basically, so it won't use that expect header if we do it this way. So let's do the same thing. H to define our own headers, and we'll do expect like that. And if you'll notice, everything here worked, completely uploaded and fine. Huzzah! If we do a reload, there's our shell PHP. So the interesting thing here, if you go back and you read a walkthrough, because I like to read other people's walkthroughs when I finish a thing, just so I, see how other people did it. Maybe they thought of something that I didn't while they were going through, or they solved it in a different way. But if you read other people's walkthroughs, some of what other people do is, instead of switching this expect to blank, they'll downgrade themselves to HTTP 1.0 instead of 1.1. I didn't look too far into this because I understand what they were doing. I didn't fully understand why. My guess is this, the expect thing, maybe we can check it out. So -0 will change it to HTTP 1.0 instead of 1.1. Let's get rid of this expect. So if we notice, the time here is 16:24:56. Yeah, so if you see, we do it in HTTP 1.0, there's no expect here, meaning expect probably isn't supported by 1.0. So this is an interesting concept, and I pointed out because this downgrade attack is what it's known as, is fairly important. It's used, I don't know if it's ever been used like this. Maybe it has, who knows? But a lot of times what it's used for is downgrading to weaker ciphers in SSL or TLS connections. you know, pretty much any crypto. If you can downgrade to say, I want to use this horribly broken cipher, or I want to downgrade from HTTPS to HTTP, and the server will let you do it, then that is advantageous to an attacker, right? So these are not uncommon kinds of attacks, even though I can't imagine how common this specific thing, downgrading to get past this expect header, is. But you know, sometimes we have to stretch our imaginations to understand why the examples in a CTF matter to us or how they're applicable. But that kind of an exercise is important because we do need to know why it's applicable. Anyways, so now we've got the shell here. We've got our server running, our handler running, and we're going to curl the and. I mean, really, this could happen either way, right? We could do the curl 6847.129, or we could, you know, click on it over here. I'd rather do curl just because, like, a lot of times you don't even actually have a web browser up. You know, maybe you don't. Maybe you only have a shell or something at your disposal. But I like to keep it up because it's better to demonstrate what's going on. So. And it's going, and we see nothing. Now, why is that? Let's have a thought. I went through several rabbit holes while I was trying to troubleshoot this. I thought that maybe I had screwed up. I was setting things incorrectly, or you know, running it incorrectly, or you know, my shell didn't work or whatever, which is ridiculous because I've exploited websites dozens, hundreds of times, whatever, exactly like this, right? And it wasn't until I realized that thought and came back and said, okay, there's something wrong happening in the process. Like something technically about this is going wrong, not my attempt, right? So let's think about what's going on. So we have a shell we have a bit of code that's going to try and hit our server or our listener on this port, this 42341 port. And the reason that we like to use these reverse shells in the first place is because it's beneficial in bypassing firewalls. So we'll you know, if we do a bind shell and make that server listen, the target server listen, we might not be able to hit it at all because like there's a firewall in front of us, maybe that port's not open, maybe that port's not being redirected to that server, etc. So we do it this way. But another thing important to remember there is that firewalls don't necessarily just block incoming. Egress firewall filters or outgoing firewall filters are becoming more and more popular, and rightly so. They definitely should be becoming more and more popular. So what's very popular in egress firewall filters is, you know, just like Nmap will only scan, you know, the 1000 or 1024 most popular ports. A lot of times people will just block anything that's not those very popular ports, and then open you know, single ports here and there as things are required. You know, maybe there's a piece of software that absolutely requires like this 42341 port, so they'll open that up for, you know, specific sockets or whatever. It's not likely. So if this is the problem, if there is a firewall in the way and it's blocking outgoing ports, what ports would be open? Very common are 80 and 443. We had touched on this in previous videos, where it's very popular and rightly so to use 80 or 443 as a listening or as a reverse TCP port, because it just looks like you know, the server or the target machine or whatever is making an outgoing web connection, which is very common. the reason that I don't normally, and the reason that I gave in that video, is that in CTFs, like locally hosted CTFs, something like NetWars, if you all have a communal jump box or a communal pivot box to pivot through various networks, and all of you are trying to initiate reverse TCP connections to the same ports, 80 and 443, or 8080 and 9000 or whatever, then you're going to get problems. You're going to have connectivity issues. Either you won't be able to bind, or somebody else will bind on top of you, or, you both happen to bind somehow, and then like you guys are both receiving each other's packets. It just gets nuts. So we don't normally do it that way I don't normally do it that way in general, but maybe this time we should. So let's kill the job that's running, and then we're going to set lport to 80, exploit -j. Now we need to remake this payload as well, because the payload is still listening on that 42341. So and if you notice, you can type in shell commands into Metasploit console. I think I've gone over this before. But if it's not a specific Metasploit command, it'll just treat it like a shell and like pass it through the shell. So you can do cool stuff like, remind yourself of what your IP address is as you're setting up the handler or whatever. So there we are. We should have a new shell. Let's, yep. 0818, is that what wow, I need to fix the time on this. Cool. So we will once again run this curl command. We're going to upload the shell.php. We're going to do it the HTTP 1.1 way. If you notice, here's the 1624.56. That has now been updated because that's when it was last modified. We now have a new shell up there. The handler has been set up. We should have a listener running, so we can verify that by running jobs. There's our handler. There's the TCP socket that we're listening on. So let's run that curl command again. Now, Did I do it on a different port? Nope, that's right. So all I'm doing is I'm going through the same process we just went through. I'm updating it to 443. That's the one I used when I ran through this before. I'm not sure if that'll fix it, but let's check this out. Okay, so we're listening on 443 now. The shell is listening on 443. There we go. Okay, so it's 443. I guess it's even blocking 80 maybe?